Hey folks, welcome back to Quick Bites of AI. Today, we're diving into one of the most fundamental concepts in machine learning, linear regression. Sounds fancy, huh? But, don't worry. Once we peel back the layers, it's not that intimidating. It'll be like discovering that a James Bond martini is just a posh way of mixing gin and vermouth. Shaken, not stirred, of course. So, let's start from the first base. What is linear regression? In simple terms, it's a statistical method to model the relationship between a dependent variable and one or more independent variables by fitting a linear equation to the observed data. Imagine you're playing detective, trying to figure out the relationship between how much coffee you drink and your productivity levels. Spoiler, it's linear, up to a point. How does it work? Well, imagine plotting your data points on a graph. Linear regression aims to find the best fitting straight line through all those points. This line is like your best guess or prediction on how one thing affects another. It's essentially saying, hey, if I know your caffeine intake, I can guess how many emails you'll fire off in an hour. Now, there are two flavors of linear regression. We've got simple linear regression. That's where we have just one independent variable. Think of it as predicting your ice cream sales with temperature alone. Then we have multiple linear regression, where things get spicier. Here, we use two or more independent variables. So, for the ice cream, we're adding in factors like location, advertising spend, or even the number of beach days. Linear regression is super handy and, well, everywhere. It's widely used in predicting house prices based on size, location, and other features. Or, for a less serious example, predicting the number of bad puns you'll hear based on the length of your car ride with me. People use it in finance, marketing, healthcare, basically anywhere there's a need to understand relationships between variables. Now, on to assumptions. Linear regression assumes the relationship between the dependent and independent variables is linear. That's like assuming you'll get a laugh every time you crack a dad joke. Doesn't work every time, but it's a safe bet. It also assumes data is homoscedastic, which is a fancy way of saying that the variability of errors should be consistent across all levels of the independent variables. And the errors? They should be normally distributed. Think of it as clean laundry. It's more pleasant when it's evenly folded and well distributed. But hey, it's not all roses. Linear regression does have its limitations. It can be overly simplistic because real-world data isn't always neat and linear. Also, outliers can throw off your best fitting line like how unexpected Wi-Fi outages can derail your latest Netflix binge. Oh, and it's sensitive to multicollinearity, where independent variables are too closely related to each other. You know, like how some sibling rivalries make Thanksgiving dinner conversations awkward. Here's a neat analogy for you. Think of linear regression like trying to draw a straight line through a swarm of bees. Each bee is a data point, and the line you draw is your best guess at predicting the direction the swarm is headed altogether. Occasionally, a wild bee strays completely off course. Those are your outliers, just doing their thing. To wrap up, linear regression is like that old reliable friend who helps explain and predict scenarios through straightforward relationships. It's a keystone in both analytics and machine learning, perfect for those starting their journey. Remember, this is just the beginning. Keep exploring and don't be shy to ask questions or get your hands dirty with more data. Thanks for tuning in to Quick Bites of AI. I hope you enjoyed this crash course and are now itching to try some linear regression on your own datasets. Until next time, keep those minds sharp and spreadsheets open.